Today we are going to talk about subtracting mixed numbers again, but this time we are going to use a different method. Last time we used borrowing. Today we are going to turn these mixed numbers into improper fractions and then subtract them. So, we have 3 and 4/5 minus 1 and 9/10. So the first thing we can do is you know what? It's almost certainly easier to find the common denominator before you turn them into mixed numbers. Or, I'm sorry, before you turn them into improper fractions. You could also turn them into improper fractions and then find the common denominator after, but you're going to end up working with larger numbers, so it actually would probably be harder to do. So let's just find the common denominator for 4/5 and 9/10. So I know that 5 times 2 equals 10. So I don't even have to change the 9/10. All I have to do is multiply 4/5 by 2 over 2, and that would give me 3 and 8/10 minus 1 and 9/10. Now, what we need to do is change these into improper fractions. So to do that, I'm looking at how this is the denominator, 10. So that means that we have 3 wholes, and 1 whole in tenths is equal to 10 over 10. Any number over itself is 1. So 3 would be, right, and then times 3, right, 3 over 1 would be 30 tenths, right? So that's 3 wholes in tenths. So to turn a mixed number into an improper fraction, we have to multiply the whole number here by the denominator. 3 times 10 is 30, and then add that to the numerator. So that would be 38 over 10. We have to do the same thing here. 1 times 10 is 10, plus 9 equals 19 tenths. And then we just subtract. 38 minus 19 is actually 19 tenths. Right? 19 plus 19 equals 38. So the answer is 19 tenths, or if you wanted it in mixed number form, since we know that 19 tenths is 1 and 9/10, we can do that. And to do this, all we would have to do is divide 19 by 10, which would be 1 remainder 9, and then 1 becomes the whole number, and then the remainder becomes the numerator. So let's do this again with this one. We're going to find 5 and 1/4 minus 2 and 2/3. So the first thing we do is we do 1/4, and we have to find a common denominator with 2/3. So the common denominator for 4 and 3 is 12. If you have no idea what a common denominator is for two numbers, you can always multiply the denominators together and you will find a common denominator. It might not be the least common denominator, but you'll be able to find a common denominator and get the answer. But you might, if it's not the least common denominator, you might have to reduce the answer after the fact. So we have 1/4 And then we're going to have to multiply that by 3 over 3, which equals 3/12. Okay? And then we have 2/3, and since 3 times 4 equals 12, we're going to have to multiply that by 4 over 4, and 2 times 4 is 8/12. So now we're doing 5 and 3/12 minus 2 and 8/12. Now we have to change these into mixed numbers, or I'm sorry, improper fractions. So once again, we multiply 5 times 12 equals 60, and then we add that to the numerator. So that is 63/12. And then we're going to do the same thing here. Minus 2 times 12 is 24. 24 plus 8 equals 32/12. So now we can do 63 minus 32. 3 minus 2 is 1. 6 minus 3 is 3. So then we are at equals 31/12. And to turn this into a mixed number, all we need to do is divide 31 divided by 12, and that would equal 2, because 12 times 2 is 24, with a remainder of 7, right? Because we're at 24, and then 31 minus 24 is 7. So that would be the remainder, and then the remainder becomes the numerator, and it would be 2 and 7/12. So this is another way of doing subtraction with mixed numbers. To be honest, I feel like the borrowing method is probably quicker, and if you know how to do it, is probably easier because you don't have to deal with these larger numbers. So I would personally say that would be my preferred method, but if you really like this method is perfectly valid too. So I just figured I would show you that.